Hello guys, in this video we are solving the problem from 46 to 50 of GR0177 paper. We are starting from problem number 46. The problem is a free particle with initial kinetic energy E and de Broglie wavelength lambda enters a region in which it has potential energy V. What is the particle new de Broglie wavelength? We have a free particle. A free particle means there is no potential, so there will be a total kinetic energy which is E, and if there is no potential, mean the particle is free, then it have total energy, kinetic energy, and in this case the wavelength of this particle is lambda. If this particle then enters to a region where there is a potential V, what will it will change the wavelength of this particle. So we have to find what is the particle new de Broglie wavelength. So we have to calculate the new wavelength. We have formula for kinetic energy is half mv square. This can be written that p square divided by 2m. This is the total energy of a free particle. In case of momentum, in term of momentum, the kinetic energy is equal to p square over 2m, where m is the mass of that particle and p is its momentum. Now de Broglie wavelength, this is given by h over p, Planck's constant over momentum of that particle. If we put this value of p, so p will equal to 2m e square root. If we put this value here, lambda will be h over 2m e square root. This is the wavelength. This one given by this formula, that h over 2m e square root. E is total kinetic energy, m is the mass of this particle. This is the wavelength when the particle is free. Now when this particle will enter to a region where there is a potential, so there will be change in energy. This is E prime, then this will be equal to total minus V. Total energy, kinetic energy, when it was a free particle, when it entered to a region where there is a potential V, so that energy difference will be equal to the net energy will be E prime. This is equal to E minus V. E is kinetic energy or total energy, and V is potential at that in this region. Now if we put here in this equation 1, then we will get the new lambda, the new wavelength. This is equal to lambda prime, this equal to h over 2m. We will put here in place of E minus V. This will be our new wavelength when there is a potential V in this region. Now to get this new wavelength lambda prime, let's divide this equation by 1. So this will become lambda prime divided by lambda. This is equal to h over 2m E minus V square root multiplied by this 2m E square root over h. H will cancel with h, 2m will cancel with 2m, so this will become E over E minus V square root lambda prime into lambda. So this is this can be multiplied here, this. So we can write that lambda, this equal to E minus V over E whole power minus 1 by 2. So this is inverting this, we can write like this. Lambda prime, this will equal to lambda into, this can be written that 1 minus V over E whole power minus 1 by 2. This will be our new wavelength when this particle enter to a region where there is a potential energy V in a region. So the wavelength will change. This lambda prime equal to old wavelength multiplied by this term. So E is the right option which match with this calculation. Next problem 47. A sealed and thermally insulated container of total volume V divided into two equal volumes by impermeable walls. The left half of the container is initially occupied by n moles of ideal gas at temperature T. Which of the following gives the change in entropy of the system when the wall is suddenly removed and gas expands to fill the entire volume? We have a box which have a volume, total volume V, and there is a wall, impermeable wall between this box, inside this box at half. This wall will divide the box into two equal volumes. The one volume is filled with a gas having n moles. This is filled with a gas having n mole and at temperature T. Now if we remove suddenly this wall, this gas will expand to the total volume. Means if its initial volume is this, so the volume will double on expansion. If this suddenly removed, the total gas expand to the total volume V. So we have to calculate entropy change in this process. Remember one thing, that the process is thermally insulated and sealed, mean temperature of the system is remain constant. So the entropy change, this is given by ds equal to dq divided by T. This is formula for entropy, change in entropy. This is the change in heat divided by temperature. Now according to the first law of thermodynamics, dq this equal to du plus p dv. This is the first statement of first law of thermodynamics. The total heat given or released is equal to internal energy plus work done. Now in this system, because this is thermally insulated, so the system temperature will remain constant. If temperature is constant, means internal energy of the system is constant, so du will goes to 0. So dq will become p dv. Now we have initial volume, let's say initial volume V1 is 1 and final volume this is 2. Because initially it is filled with half of the box, when we remove suddenly the wall, the volume will expand to its double. So let V initial volume is 1, then final volume will be 2. So dq this will be equal to integral p from Vi to Vf dv. We also know that from ideal gas equation that PV this is equal to nRT. So P this equal to nRT over V. If we put here, then dq this will become nRT integral VIVF 1 over V dV. This will then become that dq this equal to nRT ln of Vf over Vi. If we put these values, then nRT ln of 2 over 1 equal to 2. This is the change in heat. Now the formula for entropy change, this is given by ds is equal to nRT ln of 2 divided by T. T will cancel out with T, so the change in entropy will be equal to nR ln of 2. This will be our right answer. If the impermeable wall in between the box is suddenly removed, the gas will expand to the double volume of its initial, and the entropy change will be nR ln of 2. So option B is our right option. Next problem is 48. A gaseous mixture of oxygen O2 molecule having molecular mass 32 and nitrogen N2 having molecular mass 28U is maintained at constant temperature. what is the ratio of Vrms N2 over Vrms O2? Vrms is the root mean square of speed of these molecules. We have a gaseous mixture of nitrogen and oxygen, and this is maintained at a constant temperature. We have to find the ratio of their RMS speed, root mean square speed. The root mean square speed formula is given, Vrms is given by 3RT over m square root, where m is the molecular mass of the molecule. So if we take Vrms for oxygen O2, then this will become 3RT over 32 square root, and if we take Vrms of N2, then this will become 3RT over 28, because 3R and T are constant. R is the real gas constant and T is temperature, which is given that constant in this case. So we have to find Vrms N2 over Vrms O2. So dividing Vrms N2 divided by Vrms O2, this will become 3RT over 28 square root. This will be multiplied to inverse of 32 over 3RT square root. 3RT square whole square root. 3RT will cancel out with 3RT, so this will become 32 over 28 square root. If we divide by 8 by 4, this will become 8 over 7 square root. So the ratio of Vrms of N2 to O2 will be 8 over 7 square root. So option C is our right option. The next problem is 49. In Maxwell-Boltzmann system with two states of energies E and 2E, epsilon and 2 epsilon, E and 2E are the energy of two states in Maxwell-Boltzmann system, and degeneracy of for each state is 2. State the partition function for each state, the partition function is. We have a Boltzmann system, Maxwell-Boltzmann system, having two states of energy, and each energy is given E and 2E, and degeneracy for each state is 2. We have to find the partition function. The partition function is given by partition function, and Maxwell-Boltzmann is given by summation j gi is the degeneracy, j stand j for energy state 1, 2 and 3 and so on, e power minus beta ej. Ej is the energy of state. If j is 1, then this is the state 1 energy. If j 2, this is this state 2 energy, and so on, where beta is equal to 1 by kt. So we can write this summation j gi e power minus ej over kt. Now we have two states, 1 and 2. Then this will become, and degeneracy for each state is 2, so gi for each state is 2. So we will put here gi2 and 2, this is for state 1, e power minus, then if j is 1, then the energy state 1 energy is epsilon divided by kt plus 2 e power minus, this is the energy of second stage, 2e over kt. So summing this 2 and 2, e power e minus e over kt plus e power minus 2e over kt. This will be the partition function for this Maxwell-Boltzmann system if it have two energy states having energy E and 2E, and degeneracy for each state is 2. So we will take common the degeneracy 2 from these two states. This is state 1 energy, the partition function for state 1, and this is partition function for the second state. having energy 2 epsilon or 2 E. So the partition function for this Maxwell Boltzmann system will be this. So this is right in option E. So option E is our right option. Next problem is 50. At 20 degrees centigrade, a pipe open at both ends resonate at a frequency of 440 Hz. At what frequency does the same pipe resonate at a particular cold day when the speed of sound is 3% lower than it would be at 20 degrees centigrade? We have an open organ pipe and the temperature initially is at 20 degrees centigrade. At 20 degrees centigrade, the resonant frequency for this organ pipe is 440 Hz. Because the pipe remains the same in both the cases when its speed decreases by 3% of the initial when it was at 20 degrees centigrade. So the formula for speed and frequency will remain same. Now if initial speed of is V1 when at temperature 20 degrees centigrade, when temperature decreases at some cold day, the speed also decreases by 3%. So if the speed is decreases by 3%, then we can say that V2 this is equal to V1 multiplied by 3 divided by 100. We can say that the speed will decreases by 3%, so V1 will be equal to 3 multiplied by 10 divided by 100. So V2 will decreases 3% of the initial one. Now we have that V1 is, now we have that V is equal to F lambda. If this is V1, then this will be F1 lambda. If this is V2, then this will be F2 lambda. So if we take this one, this will become 0.97 V1. 0.97 V1 if we multiplied this. So we can write this as V1 into 1 minus 0.03. This will become 0.97 V1, because if 1 is the total 100%, then 3% is 0.01303. So if we minus this 3% from 1, so we will get that this speed V2 will be 97% of V1. So V2 this is equal to F2 lambda, but V2 is 0.97 V1, this is equal to F2 lambda, but we have that V1 from here is F1 lambda, so this will be 0.97 multiplied by this one F1 lambda, this is equal to F2 lambda. This will cancel out with this, then this implies that F2 frequency at cold day will be 0.97 multiplied by F1. So F1 is 0.97 multiplied by 440. So it will be also 97% of the initial frequency. So we have right option and B. So B will be the right option if we multiplied it with, so B will be right option if you multiplied 0.97 to 440, it gives 426.9. so this was the last problem of this video. Please share, like and subscribe.